Hi guys, welcome back to AP Environmental Science. In today's video, we're going to be talking about topic 2.8, which is solar radiation and Earth seasons. And as you are watching the Ed puzzle, make sure that you are filling in pages 13 through 14 in your note packet. These notes are due Monday for my White Day students and Tuesday for my Blue Day students. I will be checking to make sure that your notes are filled in at the beginning of class. And as a reminder, anything I say in these slideshows, if it's not directly a fill in the blank, you should still write it down somewhere else. I do elaborate more on pictures and the text that's shown on the screen to help you with content, to help you understand, to tie it back to previous material, whether it be in this course or in other courses such as biology. So really try and write down everything I'm saying as much as you can. It's a super helpful tip for college. I had a professor who would say one sentence that wasn't on the slides, and it would be a topic or a question on the test. So please make sure that everything that you're reading and listening to in the videos, you're also writing down in your packet, okay? So let's get started. This is the top of page number 13. Thank you. Okay, so we should know that the Earth is a globe, and the globe is divided into two different hemispheres. The northern hemisphere, which is north of the equator, and the southern hemisphere, which is south of the equator. Up here is the north. Sorry, the janitor was coming in to take out the garbage. So up here we have the north. This is the south. This would be the west over here. Sorry, this would be west. This would be east, north, south, east, west. And as a reminder, the globe is spinning west to east. Okay. So we have the sun, I don't know, over here. And the energy from the sun is going to be striking Earth. And because Earth is tilted on an axis, I forget the degree it's tilted on. It's not really that important. You just have to know it's tilted on an axis. Because it's tilted on an axis, the sunlight, the rays from the Earth strike at different points. And when you have sunlight or solar radiation striking the Earth, it's called insolation. And we should know that sunlight is the primary source of all energy on Earth. We should know this from biology. We should know that primary producers that do photosynthesis, they get their energy from the sun. So without the sun, there would be no life. Okay? So solar intensity of insolation depends on two different things. The first one is the angle of how the sunlight is going to hit the Earth. Sunlight hits Earth directly at the equator, at the equator, at a perpendicular angle. So directly, okay? Because it's hitting the Earth directly at the equator, it makes the equator really hot. Whereas in the poles, the North and South Pole, it's hitting it at an oblique angle, meaning that it's less solar intensity, lower insolation, and that makes these parts cold. It makes the poles cold. Okay. The other thing that that is going to affect the solar insolation is the amount of atmosphere that the sun's rays have to pass through. So at higher latitudes, sunlight must pass through more atmosphere and thus lose more of its energy than down here in the tropics. So what you need to know for this one is that the equator has higher insolation than the higher latitudes, which would be the North and South Pole, and that Earth is tilted on an axis. So the energy near the equator, the tropics, receive the most sunlight, while the poles receive the least. Since the surface area of the equator and poles differ, the amount of energy per square meter also differs. This is due to a difference in latitude. Some of the light that reaches the Earth's surface is reflected back. This is known as albedo. And this is something you guys might be familiar with from physics. Lighter color objects such as white, they reflect sunlight, whereas darker color objects, they're going to absorb them. Okay? This is kind of like background knowledge stuff. So lighter color objects, they're going to reflect more of the sun, whereas darker colors, they're going to absorb most of the sun. And the amount of sun that is reflected is called albedo. Clear screen. So albedo is the proportion or the amount or the percentage of light that is reflected by a surface. Surfaces with higher albedo reflect more light and absorb less. So because they're absorbing less light, they're also absorbing less heat, making them colder. Okay? So examples would be any lighter colored thing. My example here is snow and ice. They have a high albedo. A large amount of sunlight is being reflected back into the atmosphere, and a small amount is being absorbed, meaning that this is going to be colder. However, surfaces with a low albedo reflect less light and they absorb more. So this would be a high albedo. This would be high. This would be low albedo. Okay. So because you have surfaces with a low albedo, they are going to be reflecting less sunlight, absorbing more, making them hotter, more warm. And this is where we start getting into these positive feedback loops that happen in the environment. If you guys had me for biology, I know we definitely talked about positive feedback and negative feedback loops in our homeostasis unit. They don't just happen within the body, they also happen globally. There are global feedback loops, and this is one of them. And we're going to touch upon these concepts, especially in our climate change topic at the end of this unit. So what you need to know for right now, higher albedo, more sunlight being reflected, less heat. Low albedo, less sunlight being reflected, more heat. Surface temperature is directly affected by albedo. When sunlight is absorbed by a surface, it gives off infrared radiation. Areas with lower albedo absorb more sunlight, making them warmer. So because of this, we have different heat profiles all around the world, depending on, again, where you are located. So areas near the tropics are going to be warmer no matter what because they receive a really intense amount of solar insolation. However, when you're in areas that aren't getting such an intense or direct amount of solar insolation, such as the Northeast, where we are, you can still have a fluctuation of the temperatures based on albedo. And that's really important. Oh God, I look like a kindergartner write that. I'm sorry. Sorry. So this is the urban heat island profile. New Brunswick is definitely an urban area. You should know that from living here. And you also should know some of the impacts of living in an urban area, such as how urban areas really flood. Urban areas flood a lot because of the impervious surface. Oh my gosh, I don't even know if I could do this. It's really hard doing this with a mouse. They look so much better in the videos you watch. Okay, impervious surface. So urban areas tend to flood a lot because they have impervious surface, meaning that water that hits an impervious surface, it cannot trickle down or percolate through the impervious surface, leading to massive amounts of flooding. So that's one bad thing about urban areas. The second bad thing about urban areas is that they have a really low albedo, meaning that the sunlight that's coming in is not going to be reflected. It's going to be absorbed. So urban areas have very low albedo. Think about what urban areas have. They have a lot of buildings that tend to be black and gray. You have concrete everywhere for streets, parking lots. All of that is a darker color. They have a low albedo. Less light being reflected, meaning high temperatures. Okay, that is all incredibly important. And if we look at this profile of temperatures in different parts of this area, we can see that the urban areas have the highest temperature after sunset, whereas more rural and suburban areas, they have lower temperatures after sunset. Why? They have surfaces with a high albedo. They reflect more sunlight, meaning that it's colder. Whereas in urban areas, they absorb the sunlight due to low albedo. And this is something called the urban heat island effect. So the urban heat island is when urban areas are hotter than surrounding rural areas due to low albedo of blacktop. The last thing that we're going to talk about today is the Earth's seasons. Because solar radiation and latitude on the Earth's tilt, we have seasons. So again, there is the northern and the southern hemisphere. When the Earth is rotating, the spheres of the Earth are also going to rotate. When you have a hemisphere directly receiving or receiving more direct sunlight, it's tilted closer towards the sun. That season is in summer, while that area is in summer, whereas the other area or the other hemisphere is in winter. So when the northern hemisphere is tilted towards the Earth, it's summer, and that means the southern hemisphere is in winter. And then they flip-flop. Okay? When we are in winter in the northern hemisphere, the southern hemisphere is in summer. That is all I have for you guys today. I want you guys to work on this one question. I'm going to check it next class to make sure it is done. Use the image to rank the following surfaces from highest to lowest albedo. If you have any questions about this, please let me know. I am more than happy to help you all. After this, you should go and watch the next Ed puzzle, which is on topic 2.9, Earth's geography and climate. Have a good day. I'll see you guys all soon. Bye.